So a couple things. One, three things. One is your journal summary should be due sometime today, hopefully. For my class, my lab, it's due before midnight. What about the other class? Was it due already? Well, technically that's Thursday. What was it? Yeah, or at least the people who haven't turned in, that's pretty much my class. Remember, it needs to be one page. Just type in your answers. You don't have to write it in paragraph form. No more than 3 or 4 answers. Those are what the instructions say. If your instructor said otherwise, then that takes precedence. But what I'm saying, just 3 or 4 sentences, just number 1 through 8. That's all. Alright, another thing is I'm starting to see a trickling in of topics for your semester project. That's good. You should get a head start. The topics I've seen so far, which last I checked were 2, they can potentially work, but they seem a little broad. So when you pick your topic, start researching your paper. See if you can talk about what you want to talk about in like 2 to 3 papers. If you jump in and be like, this is too much information to be covered in just 2 or 3 papers, you may want to think of another topic. It happens. So just keep that in mind when you're thinking about these topics. Do some preliminary searches first. Third thing is I'm moving up my office hours, so I predict lab is going to end pretty early for my section. So instead of having my office hours from 4 to 5, I'll have them 3 to 4 in the meat locker, the lab room. So just, if you want to meet me for anything, it'll be 3 to 4 instead of 4 to 5 in the lab room. And yeah, that's about it. Alright, cool. So start out with our inaugural review question. So here is our cell. We have a high concentration of potassium on the inside, a high concentration of chloride on the outside. So without doing any math, determine the sign of the equilibrium potential for potassium and chloride. So assume the channel, the channel is working separately, so this channel is either only letting potassium through or it's only letting chloride through. And don't cheat, don't go back to your notes and try to look up the table or don't Google it or whatnot. You should be able to do this with just your knowledge. I'm not asking for a number, I'm just asking for the sign of the equilibrium potential. So take a couple minutes, talk to your neighbors. If you need to remind yourself what an equilibrium potential is, talk to your neighbor. Hopefully they know. If not, talk to their neighbor. And yeah, give yourself a couple minutes. Not much of a hint, but just in case.
Oh, okay.
Yeah, you're not going to have the internet when you're working. Not right away, at least. Just consider each ion separately when you're doing this. You should come up with 2 different answers, right?
So if the cells are going in, the steel is going to go in.
you asking what the charge would be inside and outside?
About the membrane potential. What would be the membrane potential at equilibrium?
Like just reading the words and not understanding.
That's the first hurdle.
I know.
Alright guys, let's talk about it. So, let's consider potassium first. So, you make the cell totally permeable to potassium, right? There's a chemical gradient, right? It brings potassium out, but there's an electrical gradient, right? Remember the membrane starts at -70, so as potassium leaves, it's going to make it more negative, and potassium's positive, so it's going to be drawn back in. And so the equilibrium potential is the potential of the membrane given as an equal exchange of potassiums across the cell membrane. Right? That's the idea of an equilibrium potential. So this was a chemical is pulling it out, and in this situation the electrical gradient is pulling it back in. So what's the sign for potassium? Anyone figured it out? It's a 50-50 chance you get right. Yeah, it's negative.
Oh,
It's negative. Exactly, it's negative 90 millivolts. Right? It wouldn't work if it's positive, right? If the membrane potential is positive, this wouldn't work, right? The electrical gradient wouldn't pull it back into the cell. It would just be all gushing out, right? Both gradients would be pointing outwards if it was positive, and it wouldn't work, right? So that's potassium. What about chloride? Positive or negative? Positive. Think about it this way. So, chloride, through the chemical gradient, will go in this direction, right? Chloride's negative, right? So as this goes in, it's going to make this more negative. And so what's going to happen is, in order to have something be pulled out, you need the side to be more positive, right? So, yeah, that's it, pretty much. Does that make sense, or is that a little confusing? Confusing?
Yeah.
Okay. Let's take the take the situation. So, let's prove this another way. Let's for now assume that equilibrium chloride is going to be something negative. I'm not saying it really is. Let's say it's something negative, right? If it was something negative, the chemical gradient would be pointing this way, and then, hold on. Am I getting this wrong? Give me a minute. I don't think I'm getting it wrong. Come on. Aha. I am getting it wrong. Sorry about that. Confusing myself. There we go. Negative people are right. I'm wrong. Alright. So let's do this opposite. If you assumed the chloride equilibrium potential was positive, that means the chemical gradient would be going in and the electrical one would be going in, because these are negative ions, this is positive, so the negative attracts positive, it would go in this direction, right? So this doesn't create a equilibrium, right? An equilibrium needs to go in opposite directions. That's how you can have a net zero exchange, when you can have two gradients going opposite directions and they match each other. That's how we get equilibrium. They will go both in the same direction, there is no equilibrium to be had. Does that make sense? Now that I've corrected myself. Alright. Now you may be confused and say, but wait a minute here. Why are they both negative? This is a positive and this is a negative, right? You might be kind of confused there. But what's the trick here is the gradient's in the opposite direction, right? Potassium is high inside the cell, but chloride is low, right? So that's why it's even though you look at the ions and you just think it's the opposite.